we have covered the root bridge ID. Then we have covered the RPC, root path cost, and then we have covered the sender bridge ID. Right. Further, what we have done till now is said that all the ports of the root bridge are designated ports. Right. And then we have also taken we have said this thing multiple times, that if there are n number of switches in a network, so there will be one root bridge and there will be n minus one non-root bridges, and each of the non-root bridge will have a root port. And the definition of the root port that we have defined till now is every switch which is a non-root bridge will have a root port. How many root ports? Only one. It cannot have two root ports. So something or the other has to be better for it to become a root port. So let's take one or two examples of determining how exactly you get a root port. Mark it as A. Switch 2, mark it as B. Switch 3, mark it as C. Okay. Now the cost for all these parts is same. Cost for each part is same. So the root bridge ID for this becomes so which one becomes the root bridge? This one. So this is what? Designated port. I will put it as DP. This is again designated port DP. Though we have already covered this part in the last session, but let me just recap. Sending from here, sender root bridge ID, this RPC 0. Huh?
Yes, sir.
Sender bridge ID. ठीक है. So this is this way. We have already converged to the thinking that switch 1 is a root bridge.
Yes, sir.
So we are not even going to talk that this is of course not sending any BPDUs back.
Yes, sir.
Similarly, the BPDU is coming here with what? Root bridge ID is this, RPC is 0, and the center bridge ID again is this. Okay.
Yes, sir.
The first scenario where we saw that what is the RPC, and in this way the BPDU is coming this way also.
Yes, sir. Yes, sir.
So this was coming from here,
Yes, sir.
and this one coming from here what?
10 RPC 10 32066
So this is coming from here, this is coming from there. We match this with this, both are same. We match this with this. Here's the tiebreaker. Which is better? This is better.
Yes.
That's how this has become the RP. Right?
Yes, sir.
That's how this has become the RP. Let's take another example. This again is causing a loop.
Yes, sir.
ID for this was 32768 plus B 32768
Plus 6
this is likewise plus D. Fine.
Yes.
This is what it sends here. Similarly, it sends it here what?
plus A.
RPC 0, 3276 plus 8.
Fine. What gets out sent here is
3278 plus 6.
Plus A.
RPC 10,
10
3276 plus B.
plus B.
what gets sent out here.
32768 plus A. RPC 10, 32768 plus C.
Alright.
Yes.
Now, in the previous example, we saw how to find out the root port for this switch. Right. Now, our focus has moved from this switch to this switch. So let's compare the two BPDUs coming in here.
Yes, sir.
There are two ports in here.
Yes.
One of them has to become the root port.
Yes, sir.
One of them has to become the root port. Now, how does it become? So let's compare the BPDUs coming in.
Yes, sir.
Let's compare this with this. Same.
Same.
Doesn't break. Let's compare this with this. Doesn't break. Let's compare the third thing. Which one has a better center bridge ID?
B.
H2.
This one. So this becomes a root port. Alright?
Yes, sir.
So let us recap. Up till now what we had said was not, in fact, so how do you determine root port? Right? By breaking the tie. The best BPDU received on a port. On which port is the best BPDU received? Coming from the, somehow from the
Root port.
trick, propagating from the root bridge. Somewhere the root bridge exists from where it is propagating the BPDUs. And this particular switch is going to receive BPDUs on multiple ports.
Yes, sir.
Now, which of the ports receives the best BPDU? Okay.
Yes.
Now, in the previous example, the best BPDU we determined based on the lowest RPC. But in this case, the RPC is same. But we still have to distinguish between which one is the better BPDU. So in this case, what is the tiebreaker? The lower, the better center bridge ID. Right? RPC in this case was same.
Same.
So we could not break on that. So 32768 plus B and 32768 plus C. So let us redefine our previous statement. Previously we had said RP is the port which is at the least distance from the root bridge. Was true, but there's things have changed. The two ports are equal distance,
Yes, sir.
Yes.
right? But we have to only have one root port.
Yes.
Only have one root port. So how do we find out? By breaking the tie. Alright, this is clear.
Yes, sir.
So the definition of the root port changes, and the precise definition of the root port now becomes: root port of any switch is the port which is receiving the best BPDU from the somewhere from the root bridge. It need not be directly connected. Is this directly connected to root bridge? No. It is somehow, this root bridge is somehow on the top somewhere, and then it is being received.
Okay, sir.
Right? That is where it is. Okay. Now let's continue on this topology. Okay. This is at a distance of what? 0.
Yes, sir.
Right? Now let's go back and focus on this switch. Right? Of course, we took this as an example. Let's break the loop for this topology. Somewhere we have to break the loop. So what is happening here? This is sending a BPDU.
Yes, sir.
Okay, again, keep this in mind. Don't think where BPDUs are going. So we have to consider BPDU coming here, and BPDUs, if it had to come like this, what would be the case, right? So this is what it comes here.
Yes.
But if the BPDU had to travel from here to here,
Yes.
right, the root bridge ID will always remain same.
Yes, sir.
So what it will receive here will be in the root bridge ID field 32768 plus 8. But the RPC initially here was 0. Here it became 10. Here it became 20. So which one is better, 0 or 20? 0. So that one is sure. This is fixed. Correct? So switch to root port. We are focusing and we have determined the switch to root port.
Yes, sir.
Right? So switch to root port is determined. So further, let's go back to switch 3. Again the same concept. RPC is 0.
Yes, sir.
And in the same concept we apply, the RPC in this direction would become 20, 0, 10, 20. So this becomes root port again.
Yes, sir.
So the root ports are finalized now. What are the root ports? This is the root port for this. The root port for this. This is the root port for this. Right? And wherever the root port are there, we cannot have the peak. Thus, the link cannot be blocked. This link cannot be blocked. This link cannot be blocked. This link cannot be blocked. So, somewhere here, the link is going to be blocked. Okay. So let's see which one is sending a better BPDU or receiving a better BPDU.
Yes, sir.
So what is it sending? 32768 plus A.
Yes, sir.
RPC of 10. 32768 plus C.
Yes, sir.
What would this send? It will send 327
6, 8 plus 8,
plus A
RPC
20,
20
and 3, 7, 8,
plus
plus D.
plus D.
these
Right? So compare this with this. Same. Compare this with this. This is better. Right? So this becomes a designated port. This becomes a designated port. And this becomes a non-designated port. This case,
Yes, sir.
designated port and non-designated port. So if there is a PC here having a MAC address A1 and it has to send traffic to this one PC2 having MAC address B1, source MAC address A1, destination MAC address B1, forms a frame,
Yes, sir.
send it to the switch. So it does not know the source MAC address A1, so it will learn it on port P1 into P3. So these ports are the physical ports. But what are these? These are the STP designations, naming, what type of characteristics it will have. So learned on P1, what A1 learned. And then check the destination, which is B1. Is it in the MAC table? No. So it gets flooded there, here, and here.
Yes, sir.
Let's take care of this case of this one. Alright? This one, let's say this is P1 for this and this is P2 for this. Switch 4 will also learn it.
Yes,
Port
sir.
MAC address A on port P1 will learn.
Yes,
So
sir.
populate the MAC table. Look at the destination MAC address B1. Assuming that it is not there in the MAC table, it will flood it. But this port is blocked. So can it flood that side?
No.
So this frame will not go that side. Okay. Let's continue here.
Yes, sir.
This one is okay. We'll take it.
Yes, sir.
Learn
Yes.
and flood. This side.
Yes.
This will again what? Learn and flood. This will what? Let's take case of this one. Frame reaches here. Source MAC address A, destination MAC address B. Source MAC is not in the MAC table. Assuming it's not.
Yes, sir.
We'll learn on the port P1. Say this is P2 and this is port P3. Port P1 and port P3. So learned source MAC address A on P1. Sorry, A1 on P1.
Yes, sir.
Destination MAC address B1 is not in the MAC table, so it floods it where? Here out of port P2 and port P3.
Yes, sir.
Alright?
Yes.
This one is received, checked, and it is accepted
Yes, sir.
because B1 matches B1. Here the frame moves forward. But then what is happening is this port is blocked. The policeman is standing. Just like as the frame coming from here was not flooded out of this port. Right? Similarly, the frame coming from here is blocked. Okay? The link is up. What is it? The link is up. But the port is in a condition where it is called blocking. The frames, data frames are not forwarded. What is this frame? the frame that was sent from A1 to B1, source MAC address A1 to destination MAC address B1 was a data frame, right?
Yes, sir.
So those frames are not forwarded or flooded by the NDP port.
Okay, sir. Yes, sir.
Alright, is this clear?
Yes, sir.
Okay. Cool. Good. Further, let's take another example to clarify something. In fact, so this is the DP.
Yes, sir.
Okay, let us state another condition, let us state, and that will be clear. Each segment will have at least one DP. Now, what do we call a segment? This is a segment, right? This is a segment, this is a segment, and this is a segment. Each segment will have a DP, right? Can we say that each segment will have a RP? No. Is it true?
Yes, sir.
See, first condition was true. Each segment, this segment has a DP,
Yes, sir.
this segment has a DP,
Yes, sir.
this segment has a DP,
Yes, sir.
this segment has a DP.
Yes.
Who's the DP? Yeah,
P3.
DP.
Yes, sir.
Designated port is the port which sends out BPDUs.
Yes.
And we agreed. This port on the switch root bridge is a designated port because it is originating the BPDU.
Yes.
But what am I saying? Designated port is the port which sends out BPDUs.
Yes.
Under the statement, the other statement also false. Designated port is also a port on the root bridge from where the BPDUs are originated.
Yes.
Right? So what is the broader term? Designated port is the port through which the BPDUs are sent out. Put it another way, on the root bridge, BPDUs are originated and sent out of the designated port. Clear?
Yes.
So that is the case. Here we saw them accepted and then again from the designated port they were sent out. Again, designated port originated them, right? From there they were sent out, received and then sent out. On the same terms, we can say that the root port accept is the one which receives BPDUs. Which receives BPDUs. See here, right? Here also, right? So designated ports are the ports which send out BPDUs. Root ports are the ports which receive BPDUs. Right?
Yes, sir.
Now, can we club these two statements together and say the root ports receive BPDUs which are sent from the designated ports? Root ports are the ports that receive BPDUs from the designated ports.
Yes.
Root ports are the ports that receive BPDUs from the designated port. Root port from the designated port. On the similar concept, NDP, right? See, this BPDU is still, DP is sending out BPDUs. It is sending out still, right? It is still sending out BPDUs. And these BPDUs are being received. What are they? BPDUs are being received by the NDP. Right? So who's sending them? DP. Received by the NDP. Received. Right? Received. So can we say, again, let's put the term again, DPs will always send the BPDUs. We have said RPs will always receive BPDUs. Can we also say NDPs will always receive BPDUs?
Yes, sir.
Just like we said, that the RPs, root ports are the ports that receive BPDUs from the DPs. Similarly, we can say NDPs ports are the ports will receive BPDUs from the DP. Yeah?
Yes, sir.
Clear on that part?
Yes, sir.
Okay. Now, one concept has to be put into your mind is the difference between the data frame and control frame. Control frame. Now, what is the control frame and what is the data frame? Data is the frame which is being sent from end devices, right? PC1 wants to communicate with PC2, right?
Yes, sir.
So, is that frame originated by the PC? Yes.
Yes.
Now, this BPDU, is this a data frame? No. This is a protocol frame. Isn't it a protocol frame? What is the protocol trying to see? Trying to break the loop.
Yes, sir.
So it is doing some control mechanism.
Yes, sir.
It is generating some BPDUs.
Yes,
So what are these BPDUs? Are frames, but these are control frames.
Yes,
Right? These are control frames. So and the control frames are originating at the root bridge and being propagated to the non-root bridges to break the loops.
Loops. Yes, sir.
So now you understand what is the control frame
Yes,
and
sir.
what is the data frame. Data frame is from end-to-end devices
Yes, yes, sir.
originated by the end devices and has nothing to do with the switches. Switches will act on the source and destination MAC address field of the frame and do learning, filtering, flooding or forwarding with that. Right? But the control frame is doing this, helping in facilitating the breaking of the loop. That is what is happening. Okay? So we are clear on that part. And now we have said that this particular port has become non-designated port. What has it become? Non-designated port. That means it is not allowing any data frame to go through. Right? When we had traffic trying to come from here, the destination MAC address was not in the MAC table, so it was flooded. But since this port is in the NDP state means block it. So remember the term blocking. NDP ports are blocking. That means it will not allow any data frames to go out, or will not accept anything coming in. Similarly, the frame that would come here would be blocked.
Yes, sir.
Right? Yes?
Yes, sir.
Imagine PC2 trying to send in something to PC3, having MAC address C3. What will happen? PC2 will send a source MAC address B1 and destination MAC C3. Learnt at port P2 what? B1.
Yes.
Destination C3 is not in the MAC table. It will get what? Flooded here and here.
Yes, sir.
The frame comes here. But this is in what state? NDP blocking. That means it will drop the frame there itself. Here it will come again, learning will happen, and then flooding will happen. Here and here.
Yes, sir.
Again learning will happen, and then flooding will happen. Loop is broken. Alright?
Yes, sir.
On the same concept, let's try to formalize something. Designated port. Does it accept frames? Data frame? Does it allow the frames to go through?
Yes, sir.
Right? It allows in this direction also,
Yes,
and in that direction also.
Yes, yes, sir.
Don't think about flooding and forwarding it. Is it allowing the data frame to go through?
Yes, sir.
Whether in the form of flooding or forwarding. Will it learn?
Yes, sir.
Fine. It accepted the data frame. Right? And did it allow the frame to go through this direction?
Yes, sir.
So we can say designated ports will forward data frames. Yes?
Yes, sir. Yes.
How about root ports? Will again forward? You see this?
Yes.
What is this? Frame coming from here. Root port will learn it,
Yes, sir. Yes.
right? And allow flooding here.
Yes, sir.
Similarly, root port here accepted it,
Yes, sir.
right?
Yes.
And similarly, if data had to go like this, it can go this way also,
Yes, sir.
right? So same thing.
Yes, sir.
And how about NDP? No, does not forward, right? Does not forward of flood frames, right? Okay?
Yes,
Does
sir.
not forward of flood frames. So this is basically what we call as DPR in forwarding state. Forwarding state. Right? So let me clarify something. Right? While learning the switch, forgetting about the STP, not talking about spanning tree protocol, we had learned two terms, We have learned 4 terms such learning, forwarding, filtering and flooding. Right?
Yes.
Now don't get confused between that this switch will forward or flood. This switch will forward or flood depending on the destination MAC address being in the MAC table or not.
Yes, sir.
Right? That is what the switch will do.
Okay.
But talking about a spanning tree, a particular port has to be in a state. What state? Forwarding or blocking?
Yes.
Yes.
Forwarding or blocking. If it is in the forwarding state, that means it can either be DP or RP. Let me state it again. So what is the state? Forwarding.
Forwarding.
What is the role? Either DP or RP. What is the role?
Either DP or
Role. DP or RP. State forwarding. For which? For what? STP.
Yes, sir.
So let us map it further. A STP or a port on the switch having a running STP has been selected as a designated port, right?
Yes, sir.
It will be in the forwarding state.
Yes, sir.
Does it mean that it can flood traffic or forward traffic? Yes. Understand?
Yes, sir.
In the terms of switch working of the switch, it can either flood or forward or receive traffic. Correct?
Yes, sir.
Similarly, a port on the switch running STP has been selected as a root port. Right? That means it will be in the forwarding state.
Yes, sir.
That means in the terms of non-STP part, it can either forward, flood or receive. Do not get confused that in the STP forwarding state, the switch will always forward. Understand?
Yes.
Yes.
It can still flood on that port. Right?
Yes, sir.
It can flood on that port. Don't get confused between that forwarding and this forwarding.
Yes.
Further, a switch port running STP has been selected to become an MBP. That means it will be in the blocking state.
Yes, sir.
That means whatever traffic is being flooded through that port will be dropped. That whatever traffic is being forwarded through that port will be dropped. Any traffic coming into that port will also be dropped. It's clear?